In this movie, you continue setting up the particle system you started in the last movie. Here you'll slow the particle motion down a bit into a slow motion effect. Even though this may seem a little unrealistic, it's okay to take a bit of artistic license, especially in the fantasy world of light cycles. Add a speed operator to the event. At this point, this actually looks worse than before, but you still need to adjust it. By default, the speed operator follows the direction of the p-flow emitter. Rotate the p-flow emitter in the direction of motion and perhaps a little further up. Change the speed value to 100 to slow down the motion and set the variation to about 50. Set the divergence to about 35. This looks better, if a bit chaotic. To ensure the particles settle, you need to add a gravity effect, and perhaps even a drag effect to dampen the acceleration. In the Create Space Warps panel, choose Forces from the drop-down list. Add a gravity icon and a drag icon to the scene. The icon sizes are of no importance. Next, add a force operator to the second event, right below the speed operator you added earlier. Highlight the force operator and add the gravity effect to it. Notice how strong the gravity effect is. You need to tone it down. Select the gravity icon and go to the Modify panel. Reduce the strength value to 0.01. It's better, but still chaotic. Add the drag force to the operator. At this moment, it has no effect, but that's because you need to edit the drag's properties. Select the drag icon and in the Modify panel, set its timing between frames 250 and 300. Reduce the damping values in all three axes. A value of 1 unit should work fine, but do experiment with other values. You still need a deflector on the ground so that particles do not sink below it. Create a deflector, make it big enough to collect all or most of the falling particles. Add a collision operator below the force operator you added earlier. Add the deflector you created to it. Set it to collide multiple times. A value of 3 bounces should work fine before the particles come to a stop. The bounce value on the deflector shouldn't be too high. These particles are not superballs. In the Modify panel, reduce the bounce value to about 0.2. It's also a good idea to have a bit of friction so that the particles don't slide too much as they would on ice. A value of 30% should be adequate. You're almost done. The only thing that's left is to assign a material to the particles. You'll actually need 2 operators for that purpose. The first is a mapping object operator. Place it right after the shape operator. This operator ensures each particle acquires mapping values from the surface where it originates. For that, you need to add the blue light cycle to the objects list and enable the Acquire Submaterial Index option. Since we know the light cycle has submaterials applied to it, it makes sense to enable the option. The other operator you need is a material operator, linked to the same material you applied to the light cycle. Since that material is not animated, you can use the material static operator. If material values were animated, like shifting color or noise phase, for example, you would need a material dynamic operator. So add a material static operator under the mapping operator you added a moment ago. Using the Slate Material Editor, instance the light cycle blue material into the material static operator you just defined. A common refresh issue with particle flow is that the operator needs to be disabled and then enabled again to see its effect in the viewport. You now have a very interesting explosion effect taking place. Because of the self-illumination and reflection parameters, you get some interesting glow effects on the particles that are mapped very brightly. Once you're happy with the effect, you can set the second event display back to ticks to help with viewport performance. Another option that works well is dots. Close the particle view window when done. The project is coming to an end. You still need to make the blue light cycle itself invisible after the collision impact, as it is supposed to shatter in pieces. Select the blue light cycle's body and go to frame 257. At this point, the light cycle is still visible, but should really disappear on the very next frame as the particles come into view. Right-click in the view and choose Curve Editor. Make sure the LC blue track is highlighted. From the Tracks menu, choose Visibility Track, Add. A new track is created. Highlight the new visibility track. You need to define control points at frame 257 and 258. A control point with a value of 1 makes the object visible in the scene. A value of 0 makes the object invisible. Pick the Insert Keys icon and click somewhere on the horizontal graph. Set the frame to 257 and make sure the value reads 1. Depending on your graphics card, there may be a refresh issue with the Curve Editor, but that shouldn't affect your work. Add another key. Set its position at frame 258, but this time, set its value to 0. You can zoom in to see the shape of the curve. It's a Bezier curve, but because the two keys are one frame apart, the switch-off will be instantaneous. Close the Curve Editor window and scrub the animation to see the effect. In some rare cases, and again due to graphics hardware issues, the visibility may not be seen in the viewport. You may need a test render to ensure it's working properly. Now the scene is working as you might expect. In the next and final movie, you will set a batch render process to render the scene from 3 different camera angles.